So while on one hand traditional load balancer was only giving you availability or higher availability, ADC's benefits adds agility, efficiency and security on top of the basic availability. Friends, when you hear the word load balancer, what is that first thing which comes into your mind? It is very simple. We feel that okay, this is a technology or a device which balances the load, right? Well, yes, it does, but now today the load balancer is doing a lot more than what it used to do traditionally. And the new word which has been coined to cover all these capabilities of a load balancer is ADC, which is Application Delivery Controller. You can take it as the next version or the future of load balancers. All the different technologies combined together now gives us a load balancer which not only balances the load but goes a mile ahead and give a lot of other capabilities. So we'll start with a real life example to understand this journey, then we'll go about understanding and brushing some basics and the history of load balancing, and then eventually we'll understand what all capabilities ADC provides on top of load balancer. Hello friends, welcome to ITK Funde, your own channel where we make IT interesting for everyone. And without further ado, let's get on with this story of how a load balancer went on to become what we call today as ADC. Thank you friends. If you're new to ITK Funde channel, we make IT interesting for everyone, be it IT or non-IT. We discuss all the latest tools and technologies, products, productivity hacks and career tips on this channel. So if you're new and if you like the content, do consider subscribing. Thank you. So friends, before we begin with our real life example, I would like to thank Camp Technologies for sponsoring this particular video. Camp is one of the market leaders when it comes to building products around load balancing and ADCs. They are in the industry for the last 20 years and have some pioneer products like Camp Loadmaster. I'll put the link in the description for their website and their YouTube channel. Also, I will give the link of a free Camp Loadmaster load balancer product which they provide for us to test. So please check out and learn more. So friends, let's start with our real life example. John and Smith have opened their new dining restaurant named Kitchens, or maybe should we say Camp Kitchens. And in this particular restaurant, they want to serve the finest food to their customers. Now starting when they were starting their journey, it was fine. There were few customers coming in. They were serving. They were they were in the kitchen cooking the dishes and everything they were doing on their own. But as the business grew, more and more customers started pouring into their restaurant, and they were finding it difficult to handle all the kind of requests which were coming to John Smith. It was practically impossible for them. So what they did, they hired a new person, and that new person name was Mr. Loki Bannister. Loki Bannister was appointed as the restaurant manager, and his role was to take all the requests from the customers and then pass it on to the back end kitchen to either John or Smith. And it helped them a lot because now they were only focusing on cooking and all the order management was being taken care by Mr. Loki Bannister. But as their business grew further, and with time, Mr. Loki Bannister understood the nuances of managing a restaurant. He started becoming more intelligent. He started picking up more responsibilities to make it more efficient for the end-to-end customer experience. And how he did that? One scenario. He started understanding himself that if a person comes with a specific request of a veg versus a non-veg food, he knew that John was a very good cook when it comes to cooking veg, and Smith was very good when it comes to cooking non-veg. So based on that, he started understanding the request of the customer and passing it on intelligently to John or Smith. Another thing which Mr. Loki Bannister did was that obviously while you are ordering the food, you also order some cold drinks, food, beverages which are packed, right? So instead of ordering that to the back end, he started placing those at the counter. So when any order is coming, only the order which needs to be cooked and cooked by John Smith was sent to the kitchen, while all the order which is pre-processed, which is packaged like cold drink, food, sweets, or chocolates, everything was processed by Mr. Loki Bannister. So that also added a lot of benefit. So in this way, guys, Loki Bannister, who started as a simple restaurant manager, went on to become ADC. And ADC in this case was Amazing Dining Coordinator. So now you understood a lot of things with this real life example. And now we'll go and understand how a load balancer, Mr. Loki Bannister, went on to become ADC, which is Application Delivery Controller, or Amazing Dining Coordinator, whichever way you want to call it. So let's get started with our next section. So friends, let's first start with some history of load balancer and then understanding some basics of load balancer before we touch upon the capabilities which ADC provides. So historically, load balancing was primarily started through using DNS servers. So in DNS servers, all the backend application server IP addresses were mapped, and then DNS used to send the request in a round robin fashion to those backend servers. But obviously that was not sufficient. There was no mechanism to understand whether a particular server is running or not running, whether a one particular server has more load or not. Then all those kind of intelligence was not there. So DNS worked very nicely for a substantial amount of time, but as the internet grew, as we moved on to new technologies, we had to go for the next generation of load balancing, which was network load balancer, which is also called as the founding father for what today we call as new age ADC, Application Delivery Controller. So network load balancer was primarily a physical device sitting outside your application, managing the traffic at layer 3 and layer 4. It primarily managed the TCP IP packets which were coming to this particular network load balancer. And then that itself found the base on top of which ADC went and added more capabilities, which we'll talk about shortly. So yeah, this is a quick brief history. And now let's understand some basic concepts of load balancing. So friends, to begin with, let's understand and brush up some load balancer basics. So the first and the foremost is load balancer acting as a reverse proxy. So acting as a reverse proxy means that a virtual server or a VIP would be created, which would be talking to the backend servers, and the client would be talking to this load balancer or a virtual IP which will be created within this particular load balancer. This is the most basic functioning of a load balancer, where it creates an abstraction between the client and the backend servers, so that any request which is coming from the client is going to the load balancer, and then load balancer, based on whatever intelligence it has, decides that how that particular load would be moved to the backend layer. So this layer is called as real servers. So you can see that we have app servers deployed here within 3 nodes, and then this is where we have a virtual IP. Now this virtual IP would be exposed to this particular client. So when, suppose if this client is accessing any application, they will send the request to this particular virtual IP, and then this particular virtual IP will send that subsequent request to the backend server. And this way this communication would work. So in that sense, client would send a SYN packet, and then there would be an acknowledgement, and then there would be a SYN ACK packet sent here. And similarly, the same thing load balancer will do with the backend server. But then there are also advanced mechanism where while the request going from the client to the backend server will go from the load balancer, but then an application server could directly send a response directly to the client as well. So this is also a capability which can be enabled, but yes, we are not going to that much detail. So yeah, that covers our reverse proxy and VIP. As I said, VIP is nothing but a virtual IP assigned to a set of applications. Now you can have multiple VIPs here for multiple application clusters which you want to talk to. So one load balancer might have multiple different applications, and for all those different applications, different VIPs will be created. Third is very important, which is a connection table. So every load balancer is maintains what we call as a 5-tuple connection table. And what it contains in that 5 tuple are 5 ingredients which decides the basic information which every load balancer should have. So a 5 tuple connection table should have these 5 information: source IP, destination IP, source port, destination port, and the protocol which is used for the communication. And this is what we call as 5 tuple connection table. Moving on, again, traffic distribution algorithm. Now we have talked about algorithm in my other video on GCP, but we'll just simply touch base on the basic set of algorithms which are used in load balancer. Now I have made a separate video talking in detail, and it won't be possible for me to talk about every algorithm, but these 4 basic load balancing algorithms everyone should know. Round robin, it is self-explanatory. There would be a set of servers, and based on the round robin mechanism the load will be distributed. Weighted round robin, then you will assign certain weight or weightage to specific servers, and based on that the round robin will go distributing the load. So suppose if there are 5 servers, you can add a weight to one specific server, and then the load balancer would give preference to that particular load balancer more than others. So that is weighted round robin. That weightage could be based on CPU, memory, whichever way you want to weight it. So yes, that is weighted round robin. Least connection, again very simple. Whichever server has the least amount of connections active, that particular server takes the lead in taking the connection, accepting the connection. And weighted least connection, again the weightage is added to all the server, and based on that the decision is made. Now let's talk about the last but definitely not the least functionality for load balancer, which is health checks. Now health checks is the essence on which any load balancer would work, because if the load balancer is not able to health check properly, how a load balancer would know that whether a particular server is in a healthy state or not, whether a particular node is in a healthy state or not. So what kind of health check a load balancer will do will depend on what type of load balancer you're using. Are you using a layer 4 load balancer, or a layer 7 load balancer, or a load balancer which is doing health checks at layer 2 or layer 3? Now if you are confused what are these layers, these are different OSI layers. I have created a separate video on OSI model, so go check that out. So layer 2 and 3, any health check happening at this layer is generally, if you're trying to ping a server, and if you get a response, that kind of health check is considered as layer 2 or layer 3. The protocols which we use at this layer is ARP, address resolution protocol, ICMP, echo, ping. All these kind of commands we use at layer 2 and layer 3. Very low intelligence health check, because simply it will go and see if the server is available or not. If the response comes back, that's the health check what will be done. Now if we move slightly up in the OSI model, at layer 4 it is medium intelligent, because it does it at the TCP UDP level. So TCP UDP protocols, I have made a separate video again on TCP UDP, so you can check that. So it does that 3-way handshake which we were talking about here. This kind of health check is made with the with the backend servers, and that is done through TCP. Now in UDP, you only send it, but it is a connectionless protocol. So that's why in UDP there is a timeout mechanism. So a load balancer will send a request and wait for certain time, and if no failure comes back, it would assume that connection has been successful, and the health check has been successful. That kind of a setup happens at layer 4. But now with ADC coming into picture, and with more intelligence coming into picture, we have load balancing moved up as the application layer, which is layer 7. It is the highest form of intelligence which a load balancer can possess, and it does the application level health checks. So far we are only making sure that the server is reachable, the TCP UDP protocol is responding. But what about the application? Because it might happen that your server is responding well, but your application itself is down, right? So in that sense, your layer 7 protocol makes a huge difference, because your layer 7 protocol works at HTTPS protocol layer. Okay, so suppose if there is an application, it will send a GET response, okay, to get some data about that particular application. and you can customize it. You would, if you want a certain response to be written, you can customize it. But for basic understanding, suppose if you simply send a GET request, you should get a HTTP 200 response code, status code from the from the server. So friends, here comes the interesting part. After understanding this basic, you might have that question in your mind that pretty much everything is done by the load balancer, then what's the need for ADC? So now we will understand those key capabilities which ADC adds on to a load balancer. So while on one hand traditional load balancer was only giving you availability or higher availability, ADC's benefits adds agility, efficiency and security on top of the basic availability feature. So now let's talk about all the different capabilities which ADC provides. The number one is content switching. Content switching, as the name suggests, enables a load balancer to identify what kind of content has to be routed to which particular node of the backend real servers. So suppose in this particular diagram, you can see that the JPEG files, the image files are sent to this particular node, the CSVs are sent to this one, and the jars and the application files are sent to this particular node. Now content switching could be very helpful because suppose you have an application where you have a microservices architecture where one particular microservice is doing one specific task, then on those kind of landscapes this kind of content switching load balancer can add a lot of value. So you will have one set of servers doing specifically some set of functionalities, and based on that load balancer will only feed in the data which is required for that particular service to function. So this is content switching. Now moving to GSLB. What is GSLB? Again, a very strong functionality which is global server load balancing. Now this comes handy when you are planning for disaster recovery. Suppose in this particular scenario you have two different sites at two different data centers, right? And for any reason, suppose if one particular data center is crashed or is under upgrade or maintenance, then a global server load balancer sits on top of these two sites and then routes the traffic to one specific data center or site. Now how it happens? So a client will send a request to what we call as a DNS server, and then that DNS server, instead of routing it to the actual application servers, will route it to the global server load balancer, and global server load balancer will decide that okay, for which particular site I have to send the traffic to. Now at the site level also you have your load balancers, but this is your global load balancer sitting on top of your two sites. Now it can also come in handy if you have a global application. Suppose your North America users are trying to log into your application, then this particular global server load balancer would cater and send the request only through site 1, which is in North America. Or suppose if some user from Asia is sent, maybe a site in Asia Pacific will be will be serving that particular request. So global server load balancer gives you that parent load balancer on top of your specific data center specific load balancer. So this is a very strong capability. The third is edge authentication. Now every application requires authentication, right? So take for example Active Directory single sign-on, for example. In that case, generally what happens that all that authentication is kind of a burden for the application. So application has to do the authentication and then it has to serve the request as well. So ADC, Application Delivery Controller, offloads the backend servers from these responsibilities of authentication. It will directly connect to the local AD server, your Windows Active Directory server, or any other mechanism with which you are trying to do your authentication, and then it will authenticate the valid request right at this level. So when the request starts being sent to the backend server is not bothered about or not loaded with authenticating these requests. Now this is also called as edge authentication, because we are authenticating right at the edge, right at the point where the request is entering into our system. The load balancer is sitting and validating the request. This is a very strong capabilities. So now let's talk about the fourth capability of ADC, which is Web Application Firewall, or WAF. So these ADCs also provide firewall capabilities right at the load balancer or ADC level, and this is primarily at web application or layer 7 level where these firewalls are deployed, and it provides a lot of security to your application. For example, OWASP 10, which is an open online document which talks about the top 10 most highly risky security threats for web applications. This particular firewall will already be aware of those top 10 risks or security threats which are online, which is in that particular community, and any request coming in would be scanned if that particular top 10 threats or risks are already there in that particular request. Secondly, it can also be very useful when you are using data which is very secured in nature. Suppose if your data is about the health records of the patients and it has to be HIPAA compliant, which is a very important compliance, and in GCP certifications also you will be talking about HIPAA or PCI DSS compliant. PCI is payment card industry compliance, which talks about how you have to manage the data for online payment and credit card information, all that. So your application firewall WAF will be aware of all these compliances and standards, and any request which is violating these standards will be blocked. So again, you don't have to get a separate firewall. Your ADC will have that with built-in capability within itself. So your firewall functionality will also be catered using ADC. So yes, all these are the capabilities of ADC, and now as we have talked about these capabilities, let's summarize this video with a comparison of a load balancer and what load balancer becomes when it gets ADC capabilities. So friends, let's summarize this video with a quick comparison of load balancer and ADC, but I have not written versus, because it's not a competition between load balancer or ADC, because load balancer and ADC are one family. So I have added load balancer plus plus. Okay, so what load balancer provides and on top of which what ADC provides. Let's quickly summarize this. So yes, reverse proxy, availability, health checks, load balancing algorithms, all this forms the core functionalities of a load balancer. And when we move to the ADC, application delivery controller part, content switching, global server load balancing, edge authentication using Active Directory, for example, web application firewall. So ADC also provides network telemetry. What is network telemetry? It is a process of collecting network metadata, aggregating it and analyzing it through a monitoring application. These these logs, these metadata information which are collected over time helps you to understand the overall network performance and investigate and analyze network issues. SSL and TLS encryption offload. Again, all the encryption which comes through your HTTPS request can be decrypted and offloaded right at the load balancer level. What it helps is that your application does not need to go into the intensive heavy lifting of decrypting the data. Everything is done at the ADC level or at the load balancer level. And again, compression also enhances the performance. So when suppose a request is coming from the client and then it is the load balancer or the ADC sends that request back to the server can respond with a response, and then that could be compressed and returned back to the client. So in that, this is one of the example where the request can be compressed and the size of the request or the size of the response can be compressed to enable the efficiency and the performance of your overall network communication. So yes friends, I hope this whole video was helpful, and again I will put the link of Camp website and all the details about load balancing algorithms in the description, so go check that out. I hope this was a useful video for you and you now know a bit more about load balancing and in specific what is ADC application delivery controller. Please hit the like button, hit the subscribe button. Do let me know in the comment section, have you had any experience of using ADC before? I would love to listen your feedback on this video. And yes, please keep sharing all the knowledge, keep learning, and yes, keep hustling. Bye for now.